Hey there, chemistry. This is Miss Ruark, and we're in vodcast 5.5. We're going to learn how to use the solubility rules. We're going to learn first what they are and how to use them when we're determining if a reaction happens when it should be a double replacement reaction. Okay, so in class we talked about the activity series, and we use the activity series with the single replacement reactions. Well, we use the solubility rules with the double replacement reactions. All right, so reviewing ions. Let's just go back through those again. Remember, if something is ionic or is a salt, it refers to it is a a positive ion, which we call a cation, and a negative ion, which we call an anion. And that's if you have those two together, it forms an ion. Excuse me, an ionic compound. Usually this is going to be a metal and a nonmetal, or a metal and a polyatomic ion, or a polyatomic ion and a nonmetal. Okay, so any of those would show that it's an ionic compound. All right, so dissolved. What in the world does that mean? And why, Mr. York, are you talking about dissolved? Well, we talked about the physical states. S for solid, L for liquid, G for gas, and then AQ for aqueous. So what in the world does that really mean? Well, it means that if something has been dissolved in water. So what does it really mean to be dissolved? Well, for salts, AQ means the, I don't remember what I was going to put here, but that's okay. We're going to make it up. All right, for salts, AQ means that it is dissolved in water. The ions dissociate. What in the world does it mean to dissociate? Well, if you dissociate yourself from someone, you are taking yourself away from that person. You are no longer associated with them. You're no longer said to be a part of that group or with those people or that person. So if ions are going to dissociate, they're going to actually break apart. Okay, so NaCl, AQ, is saying it's the same thing as sodium ions floating around in aqueous solution and chlorine ions floating around in aqueous solution. Okay, so acids will actually form ions where you'll have the hydrogen ions floating around and you'll have the chlorine ions floating around, in this case because it's hydrochloric acid. And guess what? Bases also form ions. And they're going to break apart into sodium ions, and in this case, hydroxide ions. Okay, so they're breaking apart into the ions that make them up. And that's what it means to actually dissolve something and become aqueous in solution. Okay. So how is the charge determined? Well, remember the charge is determined by the number of valence electrons for that element. So we know this already, but this again is just review, and for some of you it's a great review. Okay, so fluorine and chlorine, those are both going to be in the halogen group, which is the group 17. They have 7 valence electrons, and in order to become like the noble gases next to them, they need to make 8 valence electrons, or they need to have 8 valence electrons. In order to make 8, they have to take 1, so they're going to gain 1 electron. And when they gain 1 electron, it's going to form a -1 charge. So you're going to end up with fluorine with a -1 charge and chlorine with a -1 charge. Okay, well, calcium, another example, this is a metal, and metals lose, they give away. And calcium has 2 valence electrons. Well, metals are going to give away all of their valence electrons, so calcium is going to give away 2 electrons, thus forming calcium with a +2 charge. Okay, just review. All right, so let's write these ions from the formula. So if we had Na2CO3, what are the 2 ions that make up this compound? Well, when we put it into solution, it's going to break apart into sodium ions. Okay, and we're going to have 2 of them, right? Yeah. What charge does that make? It has a +1 charge. And then we have how many CO3s? Don't say we have 3 of them. No, we put the parentheses around it that says, hey, that's carbonate, and we have 1 carbonate, and that carbonate has a -2 charge. Excuse me. All right, so the ions for calcium phosphate aqueous and cadmium nitrate aqueous. Okay, now if you think you got this, go ahead and pause it and then come back and check your work. Okay, calcium phosphate is going to break up into calciums and phosphates. Just listen to the name. Okay, so we're going to have calciums with a +2 charge, and we're going to have phosphates. And phosphates, there are -3 charge. All right, so how many calciums do we have? We have 3. And how many phosphates do we have? We have 2. And there you go. Cadmium 2 nitrate. Well, we're going to have cadmium with a +2 charge, and we're going to have nitrates with a -1 charge. And there's 2. So there you go. Easy, right? Easy. All right, if you think you got this, keep going, and then check your answers. If not, you can keep working with me. All right, so sodium sulfide. Sodium with a +1 charge, and sulfur with a -2 charge. How many sodiums? 2. There you go. And then for the last one, magnesium, this is borate. Borate. Yes, okay. So this is going to break apart into magnesium ions. There's 3 of them with a +2 charge, and 2 borate ions, BO3. What kind of charge is it going to have? Oh, look at that, a -3 charge. Isn't that cool? All right, so see, this is easy, right? Well, you need to know that. Why? Because we need to have that when we do our double replacement reactions. You also need to know that because when we get into the next podcast, we're going to be learning how to do net ionic equations. And to do a net ionic equation, you have to be able to break something up into the ions that make it up. All right, so solubility rules. There are some rules for solubility that ionic compounds must meet in order to determine if they are solid or not solid or aqueous. Okay, so here's a list of the rules. These rules right here have not been given to you. So there's a good chance you'll probably want to pause and write these down somewhere. I don't think they're in your vodcast notes. So again, you might want to pause and write this down somewhere. Okay. All right, so here are your solubility rules. If something is soluble, that means that it does dissolve. And if it's soluble, it's going to be aqueous. Okay, so everything that is soluble is aqueous. It means it can dissolve. Excuse me. If something is insoluble, that means that it cannot dissolve. And so it's going to be a solid. All right. Anytime you have an alkali metal, so it's a group 1 metal, and this should say ammonium, not ammonia. Anytime you have an alkali metal and ammonium, it's going to be soluble. So an alkali metal would be potassium, lithium, rubidium, cesium, right? Or ammonium. So anytime you see any of those at the beginning of a formula, it's going to be soluble. Okay? And when you do these rules, I like to number these 1, 2, 3, 4, 5. And I just like to go, you always start at number 1 and go down until you find a rule that fits. If the rule doesn't fit, you go to the next one. As soon as you find a rule that fits, you stop. If you don't find a rule that fits, we say, guess what? It doesn't matter. It's soluble. Okay? All right, so nitrate salts and chlorate salts. So anything that's going to have NO3 and anything that's going to have ClO3. Okay, the nose and the close. Yeah, I know it's stupid, but I don't care. Okay, and then we have our sulfate salts. So anything that has sulfate in it is going to be soluble, except anything that has lead, silver, or mercury. Okay, lead, silver, and mercury. I like to call those the 3 horsemen. Nasty little boogers. All right, and then barium, strontium, and calcium. They're kind of nasty too, but they're okay. They're okay in my book. All right, so anytime you have Ba, Sr, Ca, Pbag, or Hg with SO4, it'll be solid. Okay, so these will all be solid. Otherwise, it's aqueous. All right, chloride salts, which means that it has Cl, chloride. Those are going to be aqueous unless it has one of the 3 horsemen. Lead, silver, silver, and mercury. Those would be solids. Notice how lead, silver, and mercury are always solids, right? Yes. Okay, and then for the last ones, we have the carbonates, CO3s, we have the phosphates, we have the chromates, the sulfides, and the hydroxides. These are all going to be soluble. right? So it's very easy. All you do is you start at the top and you keep going down until you find a rule that fits. And if you can't find a rule that fits, we say it's aqueous. All right, so how do we use this? Well, circle the compounds that are insoluble. So the ones that are not soluble, these are the ones that are going to be solids. Okay. So the best way to do this is just X out every one that's not going to work. So let's go back and let's look for rule number 1, salts of alkali metals and ammonium. So over here, alkali metal, no, it's alkaline earth. So this one's not, doesn't count yet. Copper, nope. Ammonium, yes. All right, so this one, oh, where'd my pen go? Go back. I need my pen. All right, so any one that's going to be aqueous, we're going to cross it out. Okay, this one's aqueous. Why? Because it has ammonium. Okay, iron is not a group 1 metal. Cesium is, so we're going to cross it out. Silver is not a group 1 metal. Cadmium, no. Copper, no. Lead, no. Barium, no. Sodium is, so we cross it out. Ammonium, it's a group 1, or it's ammonium. So we cross it out. Strontium, nope, it's group 2. Hg, no. Na, yep, so we're going to cross it out. Ba, nope, that's group 2. Pb, Ca, nope, group 2. This is an acid. Yeah. Okay, sorry. We're just going to keep going. All right, and then magnesium, nope, group 2. Okay, so we eliminated all the ones that are aqueous because of group 1, because of rule number 1. All right, next rule, nitrate salts and chlorate salts. So we go back. Anything that has nitrate or, oh, so annoying. Okay, anything that has nitrate or chlorate. This is chloride, not chlorate. Okay, nitrates or chlorates. Do we have any nitrates or, yep, there's a nitrate. Nitrates or chlorates. Okay, there we go. Now we go next. Sulfate salts. So if it's a sulfate, it's going to be aqueous, unless it has the 3 horsemen or it has barium, strontium, or calcium. All right, so that's sulfates. Sulfates. Here's sulfates. Barium, strontium, calcium. What was it? Barium, strontium, calcium, lead, silver, mercury. Is it one of those? Nope, it's going to dissolve. Okay, see how I did that? All right, keep going. Sulfates. Nope, that's not sulfate, that's sulfide. Sulfate. Pb. Yes, this one will be a solid. Okay. Oh, hey, we got one. All right, we're done with that rule. Okay, so let's go back and let's see. Chloride salts will be soluble except for the 3 horsemen. All right, so chlorides with the 3 horsemen will be solids. Here's one with the 3 horsemen. It's a solid. The rest of them are okay. All right, we're good. Okay, next rule. Carbonates, phosphates, chromates, sulfides, and hydroxides. Okay, so that's a lot to remember, right? Okay, so it was carbonates, phosphates, hydroxides, sulfides. What was the other one? Chromates. Okay, this one doesn't apply to any of the rules, so it must be aqueous. This one, oh look, it's a sulfide. This is not any of the rules. It's a hydroxide. Oh, look, it's a hydroxide. Nope, not any of the rules. Not any of the rules. Not any of the rules. None of the rules. None of the rules. And this one's a carbonate. Okay, so that way we've gone through and we've been able to tell which ones would be solids and which ones would not be solids based on those solubility rules. We're going to practice more when you get into class, so this will make a little bit more sense when we get there. Okay, and here's just a little something to leave you with. I know we talked about polar last year, but I thought it fit. So, all right, y'all have a good night, and I will see you tomorrow.